So yeah, when documenting the quality during digitization, we will talk about metadata. So what exactly are metadata? Metadata are simply data about the data. So you can use metadata to describe the content, the accessibility, the completeness of the dataset. So in the metadata, you can add a lot of information. You can also document the errors that your dataset may contain. And you can also document the validation process, the data cleaning, and data correcting process. So in theory, in an ideal world, metadata must be rich enough to allow data use or reuse by a third party without them having to refer to the data source. So it's the metadata that will give the user context about your data. So what do you do when you have some taxonomic data? So first of all, what are taxonomic data? So we talked already about the different origins of data, and we talked about taxonomic data, but here are a few reminders about the taxonomic data. So it can be names, they can be scientific names, vernacular names, ranks, hierarchy. You can also have some status. This name is a synonym of this name. This name is valid. This name is not valid anymore. You can also have some references, such as the author, the date and location of the description of the species, the identification, who and when was this specimen or individual identified. And you can also have some quality terms related to taxonomic data, such as the ID certainty, for example. So in the case of taxonomic data, scientific and/or vernacular names are the entry point to retrieve and to have access to the data. So the risk of propagating errors during the whole data publishing process is really great in the scientific or vernacular name. So below are listed some possible errors and solutions. So the most common types of errors are incorrect identifications. So in this case, if you are not sure about the identification of a specimen or an individual, you should call for help from a taxonomist. So it can be one of your colleagues or an expert in taxonomy, so someone who is a reference in taxonomy. Then we also can find a lot of typos in taxonomic data. So, and especially in scientific names. So typos can be cleaned during data cleaning process that we will see later in this training. And then we can also have some errors when data are in the wrong format. So, for example, when you put the scientific names in the wrong column, or you can also fix that using data cleaning process. And the errors can affect scientific and vernacular names from all taxonomic ranks. So you have to be careful about the scientific name table or column, but you also have to check all the taxonomical ranks in order to be sure that your data are correct at every taxonomical level. Some other common mistakes to avoid regarding taxonomic data are missing data. For example, when you have the subspecies that is mentioned but not the species, so it can just be an omission, and it can be fixed easily. You can also have some incorrect values, so such as typos or wrong columns or even symbols. So if you have some incertitudes about the data, you should leave the spreadsheet cell blank instead of leaving symbols like interrogation points or anything, because it can really affect the quality of your data. Then you also can encounter some non-atomic values. For example, subspecies Bicostasa in a single term. So in Darwin core, the standard that is used within GBIF. There's a field for the subspecies rank and another field for the subspecies value. So you must be careful not to merge these two fields in a single term. One of the common mistakes regarding taxonomic data can be duplicates. So, uncertainty on at least one name of the binomial nomenclature. So if you have some doubts about the identification of your individual, if you have some doubts about the species, for example, the best thing is to leave to stop the identification at the genus level, and then you can ask for help from an expert about the identification of the species. So it's best to leave the identification at a higher level than to share an incorrect identification. Then you can also have some duplicates, so that can be synonyms or several valid names for the same species. So here again, you have to check and use only one term, only one name, sorry. And you can also find some inconsistent data after databases fusion or when using several checklists. So here again, you have to be sure that you only use one referential for each of your data, and that everything is consistent and congruent. So after the taxonomic data, we can also deal with spatial data. So a definition of spatial data is on this slide. So you can see that spatial data can be textual or georeferenced. So textual can be a name of a city or a county or country, and georeference are some numbers that are the latitude and longitude of your data. So spatial data are one of the key information to determine the fitness for use for biodiversity primary data. So they can be used for species distribution modeling, selection of areas to protect, resources and environment management. So it's really important to have spatial data. So you can do your best to fill in the special information that you have about your data, even if you don't have a GPS or even if you don't have the geographic coordinates for your data. At least you can always put the name of the place where the data were recorded or observed or collected. And if you can go back to these places with a software or a device to record the coordinates, so you can do this at a later time. So when we talk about spatial data, we are talking about most of the time latitude and longitude, or sometimes some areas or point and radius, or a bounding box, which is a rectangle calculated from the coordinates of 2 points, or sometimes polylines, or even grid references. So in the next slide, I will show you what a grid reference is. So here you can see some data based on a grid. So you can see that sometimes the data are not some points, but there are some cells on a grid. So it's not as precise as some points with real coordinates, but it can be helpful when you have some atlas or data that are collected on a large scale. So for a few more definitions about spatial data, here we have the definition of coordinates. So a coordinate is a code documenting a position on Earth expressed with a spatial reference system. And most of the time, coordinates are latitude and longitude. So it's always the two coordinates together. If you have only a latitude or only a longitude, it will not work. You need to have a latitude and longitude to be able to reference the position of your data on Earth. Then georeferencing is the process of assigning a geographical reference to a given record. So that's when you can do that at the time of the record. So when you are on the field and you have a GPS, or you have checked the georeference of the place you are in, or you can do that at a later time using GIS software or a remote system or anything else. And datum is a geodetic system, and it's really useful to know the datum that you are working with, because it's really useful to give the datum as well as the coordinates. So as it was the case for the taxonomic data, there's also some common mistakes to avoid when we are dealing with spatial data, such as coordinates inversion, null values, unknown datum, inadapted SRS, and conversion issues. So on the right of this slide, you can see, and this is an old map that was used by the GBIF a few years ago. So the maps on GBIF are not the same right now, but this is only to show you that before the GBIF implemented some automatic correction of georeferences, you can see what were the problems before. So here you can see that on the United States, sorry, you have a lot of data, but you can see a mirror effect on China on the right of the map. So this is due to an coordinates inversion. And you can also spot other mistakes on this map. So for example, you have a line in the center of the map, a vertical line, that is the Greenwich meridian. And it's due to the fact that some people, when they didn't know the coordinates of the data, they just put 0 in longitude cell. And you can also spot the same mistake for the equator line, which is the 0 for the latitude. And you can also see a small mirror effect of the United States data on the west of Chile in the South Pacific, which is due to an coordinate inversion, but with the latitude this time. So this map is a great example to show you what can be wrong with geographical data. So you have to be sure that your data are well georeferenced, and you have to check that there's no errors of this kind. So now we are talking about the collection data. So at first, some definitions. So when we talk about collection data, we talk about the collector names, the collection date, and some additional information such as habitat or soil or meteorological condition. So the relevance of this data about collection depends on the dataset type. So if you have a static collection, such as a museum, for example, a museum collection, you will need the collector name and his ID. The date of collection, maybe the habitat or the capture technique. When you have a static collection, such as a museum collection, you will need the collector name and ID, the date of collection, the habitat, and maybe the capture technique if you have it. So sometimes you can extract this information from the labels. Sometimes you have access to the notes or the field books that were used at the time of the collect. Sometimes it's recent specimens, so you can talk to your colleagues and ask them what was the context of the collection. But sometimes you don't have this information, so you might have to retrieve this information using other materials. Then when you work with observations, you can need some additional information about collection, such as observation length, or the area, or the time of day, the activity, the sex of the observed specimen, what they were doing. So you can add a lot of information about this kind of data. And then you can also have some data that are more sampling event data. So here you will need to document the sampling methods, the grid size, the frequency, the collection of reference specimen, and anything else that could be related to the context of the sampling event. So when we are dealing with collection data, we can have some factors that will have an impact about your data quality. So we will talk about exactitude about the names of the collectors or the date. So you have to be sure that the collector's name is with the good is well written, and that the date is correct too. So you can do some background checks. So for example, if you have some specimens that were collected by a naturalist from the 19th century, and that the date of collect is 2013, you will see that something's wrong, and you have to check what is the correct date. The consistency of the data. So you should use a control vocabulary in order to standardize your data. The completeness of your data is also really important. So some terms are very rarely completed. For example, the flowering periods for plants or trees, associated species in the case of parasites or symbiotic organisms. So it can be really useful for you, for your colleagues, for later users of your data to know which species were associated with your specimen or with the individuals that you observed. So if you have this information, so you should add them, even if you think it's not interesting. It can be interesting to someone one day. And to finish this presentation, we will talk about descriptive data. So descriptive data are of variable quality. So for example, historical data are impossible to check. So if a specimen was collected 300 years ago, it's nearly impossible to check the context of its collect. So unless you have some really precise logbooks or any kind of literature that can help you, that gives you details about the context of this collect, you have no idea of what the collector saw, so you cannot make up the missing details. Sometimes data description is too expensive on time and or money, so people don't do that because it takes too much time and it's too expensive. Sometimes some data are subjectivity is to be taken into account. For example, for color or abundance estimation. Often, most of the time, data relative to the whole taxonomic rank and not the specimen in particular. So the descriptive data are often made about the whole taxonomic rank and not a given specimen. So you have to be sure that this also is right for your specimen. The completeness of your data is also to be checked. So it's generally impossible to achieve completeness on a given specimen because you just cannot have all the information, but sometimes you can fill in the blanks with some information that were collected about another specimen of the same species, for example, or a specimen that was collected at the same time at the same place. So if you forgot to note for one specimen the weather information, for example, and that the weather information were consistent for the whole day you were on the field, you can check with another specimen that you collected at the same time and just copy the weather information. But you have to be sure that it is correct. And sometimes you have to check that the traits are consistent between them. So in a database, if you have some description of a flower color, for example, and you can see here that we have an example just at the end of the slide of two shades that are really similar, so carmine and crimson, describing the same flower color. So if you notice this kind of error, you have to be sure that it's corrected by just merging these two traits and just keeping one of the two. So thank you for your attention, and this is the end of this video.